Chapter 5 begins talking about the binomial probability distribution. 5.1 is random variables and probability distribution. I kind of want to take you a little bit back to your algebra days. For some of you, you may love revisiting this. For those of you, you may not. But if you had two events, sometimes we could illustrate this as something like factors and their binomials. And we did something like that and we solved in algebra. Like we would set each of those equal to 0 and kind of solve. It's not like we're doing that, but a binomial event is dealing with two things. So random variables. A quantitative variable x is a random variable if the value that x takes on in a given experiment or observation is a chance or a random outcome. So number of eggs in a robin's nest could be an example of that. Measuring daily rainfall. Counting the number of defective light bulbs in a case, or measuring the weight in kilograms of a polar bear. So we just call those random variables, a quantitative variable. And there's a couple types. We have discrete random variables. These can only take on finite numbers of values. Basically, they are countable. So for instance, that list above, the number of robin eggs, you can count those. Or the number of the defective light bulbs. Those are two examples from the list above that are considered discrete random variables. Continuous can take on any number of countless numbers of values in a line interval. So again, like going back to discrete, we could count them. They're countable. Whole numbers. Daily rainfall could be 1/2 inch or 3/4 of an inch or a 1/3 of an inch. You know, could be fraction numbers. And it could go on and on. So maybe it's not an exact whole number. That could be a way to think the difference between discrete and continuous. Discrete is countable, continuous, maybe it's a decimal number. So like daily rainfall, when you measure daily rainfall, it's never an exact measure, right? You always have 5/8 of an inch or whatever, and weight is never an exact number. So of those two, of these two out of the 4 above would be considered continuous random variables. So example, let's practice that. What type of random variable are the following? Time it takes to complete an exam. So that could be continuous. In my opinion, maybe you could argue it's discrete, but like if you had an actual timer, thinking about runners even, you know, and you started the stopwatch and you stopped it, it's probably not going to stop very often on an exact second digit. Number of bad checks written in a day. That's kind of an awful example, isn't it? That would be discrete. You can count them. It can be a whole number. Amount of gas put in a vehicle would be continuous. As hard as you try, you're probably not going to get to the exact drop of an exact gallon. Number of registered voters in a district. That's just, you can't have a part of a person. So it's discrete. So let's turn the page and let's move on from that. Oops. Get my remote out of the way here. So probability distribution. Assignment of probabilities to each distinct value of a discrete random variable or to each interval of values of a continuous random variable. Probabilities for each random variable X. So we're going to be given an example of what this means, an assignment of probabilities. It says to be a probability distribution for a discrete random variable. The first thing is there is a probability assigned to each value of the random variable. And the second thing that we need to always remember is that the sum of all these probabilities must equal 1. So we have a little chart here that kind of helps us with this example. It says, for example, X is going to equal the number of appliances sold on a given day. And F is going to be the number of days that many appliances were sold. So for zero, there were 0 appliances sold for 9 days. There was at least 1 appliance sold for 72 days. 72 days out of the calendar, the given amount of days that they were observing, for instance. 2 for 63 days of it, 3 for 41 days, and on and on. You would probably want to know total days. So this would be number of days. You may want to label it. And this would be items sold. So I'm just going to put numbers sold. That's what these numbers represent. And when you would probably want to know, or you'll need to know the number of days that were total, which there were 240 days that they were observing and tallying up for the frequency of how often it occurred when they sold 0 appliances or 6 appliances. And so all we do to assign the probabilities of each of these is I'm going to write assign probabilities, because that's what we're doing, is that relative frequency. We take our frequency, divide it by the number of times number of days, total number of days. And I think in WebAssign, because you're going to see some decimals, I think they ask you to round to 2 digits. So that's what we're going to do for our rounding instructions. But always follow rounding instructions in WebAssign if they do differ from what we do in Notes. I try to follow it. Sometimes I make up my own instructions, apparently, that don't go along with how they do it. So the probability of 0 appliances being sold would be 9 days out of 240 that happened. And so if you go plug that into your calculator, you're going to get something like 0.0375. I'm not going to pull my calculator out. I know you guys can type it in, but do it yourself. And then we would round to 0.04. The probability of selling 1 out of those 72 days, so 72 out of 240, when we round that to 2 digits would be like 0.30. The probability of 2 is 63 divided by 240, which is 0.26. The probability of 3 being sold, that happened 41 days out of the 240. So when you divide that and round, you get 0.17. Let's finish this list. If you want to pause and do it on your own, you're welcome to do that. So as you can see, it's not really hard. It just can be time consuming. It's easy math. It's just knowing what to do. So these are all the probabilities, like a 4%, 30%, 12% chance. When you go sum those probabilities, just as a reminder, that's your sum symbol. That means if you added all of those together, it will equal 1. And I've done it on my calculator to double check it. You do it. If it doesn't, you either rounded wrong, or sometimes there can be really slight errors in it, and it'll be really, really, really close to 1, but it should equal 1. So find the probability that 6 appliances are sold on a given day. So that's just looking at your chart. The probability of 6 was the 0.03 from our chart. So it's just regurgitating what we just found. After we assigned the probabilities, we figured the probability of each. And you're going to be doing a lot of explaining in this. And, you know, as an online course, you're not having to do as much on paper to write out your own sentences, but you will have to pick from some multiple choice things. So, you know, you need to kind of get in the habit of looking for some things like maybe it'd say the probability of selling 6 appliances on a given day is 3%. So you'd want to turn that back kind of into a percentage to answer that. So again, if you're an online student, you don't do as much writing on some units as others and explaining, and mostly you just need to pick out the best statement. So you should still be kind of practicing that. When we find, you know, this data, or, you know, we find these probabilities, it should mean something. And so we should be able to explain it. My in-person students, when we test, we always have to explain it. And that's part of our testing. My online students, you do have proctored tests, and so you'll have to know how to explain it, and I do those on paper for that reason. So it's a good thing to practice. It's not just something we do in our notes and never do it again. So do pay attention to that explain portion. Don't just skip over it because it's kind of done for you in WebAssign. So really that applies to all in-person and online students because you have to do it at some point or another. Everybody does. Find the probability 2 to 5 appliances are sold on a given day and explain. So that would be like saying the probability of 2 is less than or equal to, because we are including 2. So we'll do the equal to X, which is less than or equal to 5. So what that means is you're going to add all those probabilities all up together between those the probability of 2, 3, 4, and 5, basically. So the probability of 2 appliances selling, plus the probability of 3, plus the probability of 4, plus the probability of 5. And so you're just going to go to your table to find those probabilities and add them up. So that'd be 0.26 plus 0.17 plus 0.12 plus 0.06. And that gives us 0.61. So again, that's the probability as a decimal. And if we want to make application sense of that, we would turn it into probably a percent. So there is 61% chance of selling 2 to 5 appliances on any given day. Some people get super fancy and say calendar day, any given calendar day. I don't know why. To me, you're repeating what you're meaning. All right, so let's turn the page, and it says, find the probability at most 2 appliances are sold on a given day, explain. So if it says at most, that means no more than 2 is how you would interpret that, is the word I was thinking. I was a little slow trying to think what it meant. So we would say the probability of X being greater than or equal to, or less than or equal to 2. So the probability of selling 0, 1, and 2 is what we're adding together. So the probability of selling 0 plus the probability of selling 1 plus the probability of selling 2. So we have 0.04, 0.30, 0.26 that we're adding together. Those numbers come from that chart on the page before. So this would be like 0.60 when you add them together. So in our explain, I would write there is a 60% chance of selling, and it's kind of back into the question word verbiage of selling at most 2 appliances on any given day. So a graph of a probability distribution. We need to put the probability on the vertical axis, right? So that's your P of X value. That's going to be these values here. And then you're going to put the random variable on the horizontal axis. So that's down here. So that's how many appliances were sold. So number of sold. And then this would be the probability or your frequency, which is what we learned in Unit 1. Okay, so the probability of 0 selling, 1, 2, 3, 4, 5, 6, and I think the chart went to 7. Let me go back to the page before. So yeah, 7. And then it looks like we go anywhere from 0.04 up to about 30 is the biggest. So I'm going to go by 0.05s. In graph. So the probability of 0 was, got to turn my table back over, keep doing that, was 0.4, so it's just below the 0.5, 0.04, sorry. Of 1 was 0.30. And I don't know why I did it quite like that. Doesn't really matter. Let's pretend it's just a fat bar. Okay. My graphing skills are not beautiful today. 2 is 0.26. That's going to be above 0.25. 3 was 0.17. So that's going to be somewhere right here. 4, 0.12. So it's going to be a little bit in here. 5. 0.06, so just above 5. And 6.03. And 7.02, even smaller. There you have it. So we just make a graph. Sometimes we have colors that help us separate the graph and make it look a little bit prettier. I didn't have a fantastic looking one, but we did it. And just as a reminder, we learned about distribution shapes. Remember this one, if we went over that, that would be skewed right. All things to just kind of pay attention to, kind of builds on each other. You should always title your graph. We did label them, but let's title. And remember, this was appliances sold per day. So there's our title. So our mean, when we're dealing with our expected value, is what this is called. Our mean is our expected value. That's found by using this. Okay, remember this symbol right here is mu. So when we find our mean, remember that could deal with the sample mean or the entire population's mean, which is always given to us. Our standard deviation, there's a formula here. We're going to be working with this on the next page, applying it. Standard deviation might just be the letter S. but then the sigma means of the whole population. So the standard deviation, when it's the S variable, it deals with the sample, the standard deviation of the sample. This is of the population. So just make sure you remember those two things. If you do, you'll be good for the entire semester between those two values. So appliances, we're going to be using our mu equals the sum of your X times the probability of X, so that frequency that you found. We'll have to find the frequency. So it says here, find the expected number of appliances sold in one day. So we're still dealing with that same chart. All of these values are still coming from here. So we know that the X, and you may want to make like a little T-chart, that's really up to you, and P of X, but we're multiplying these things together. Okay, it's not making like a ordered pair or anything, but we're taking 0 times 0.04 and we get 0 out of that. That's what's happening here. And then we're going to sum them up on the outside. Okay. For one, we're taking that times the probability was 0.30, so that would be 0.30. 2 appliances was the probability is 0.26. So when we multiply that, we'll get 0.52. 3 appliances is multiplying times 0.17, which gives us 0.51. 4 appliances, 0.12. I'm putting these dots here, trying to make them big. You could also put these in parentheses if you wish. Totally up to you. You didn't even have to make that line down the way if you didn't want to. To me, it just keeps the two things a little bit separate. Okay, 0.48. So then we're going to sum these. We need to add these together. So I'm just going to write it underneath here. So the sum of all of that is 2.43. So we'll find the standard deviation underneath all of that, since I kind of used a little too much paper up there. So what this means is when we sum that up, that means the mean of all of that is 2.43. That meant the reason we're using the mu is because we used every single day out of the 240 days to get this data. So that's why it's using the entire population. And so if we explain, even though it doesn't tell us to, we have to get in the habit of doing it quite a bit. It says on any given day, or a given day, I can expect to sell. So what this means is that we could sell between 2 and 3 appliances. To sell between, or I could just write 2 or 3 appliances. Would be a good way to state that. So we're going to next find the standard deviation. The instructions I squiggled out because I wrote past it. Try to keep my work in line. So standard deviation, you're going to be using, you have that little sigma symbol equals the square root of the sum of, after you do all this math that's going to be in the bracket, you're going to take your X minus your mu. So you just found the mu up there. So that's going to be in every single problem that we do. And then you're going to square that and take it times your probability. So we're gonna do all that math, then we're gonna add it, then we're gonna take the square root of it, kind of work our way inside out of this. So I do a little chart with this as well, kind of helps keep it organized. My x minus my mu squared times my p of x. I'll try not to write so big so I can keep it all together. And you can put a line down it if you want. I may not this time. But like if I sold 0 a day and subtract the probability that we found below above and squared it, then I take that time 0's probability of 0.04. That might help. And then we do that math, that's going to give us 0.24. So you need to make sure you put that in a parentheses, otherwise you're going to get a funky negative, and I can't get a negative probability, right? Negative numbers can't happen, can't have a negative probability. 1 minus 2.43 squared times 1's probability, which was 0.30. So you're going to plug all that in your calculator. It's a little time consuming, but then you'll let your calculator do it and get 0.61. So we're going to do that for all of these. Multiply times all, subtract all of them by the 2.43. To do 7 different ones, 7 calculations. So understanding the formulas is just the biggest part of all of this. If I'm writing too fast, you're welcome to pause it, write yours, and then rejoin me. If you're calculating each one, you'll definitely need to do that as well, which I do recommend you do a few at least on your own. Um, 0.38. I've calculated them just because lecture video, it's good to kind of move along and assume that you know how to use your calculator. Okay, so when you sum all those up, we get 2.47. So what we're going to say is on any, oh, we're not done though, right? We summed those up. Now we have to take the square root of that. So I usually do that with a different pen color. I can't find my pen color. So because of the formula to find our sigma, we take the square root of 2.47. And we would get, rounding it slightly, is 1.57. Remember what standard deviation represents. It deviates that much from the mean. So if we were to explain this, we'd say on a given day, well, let's go back. If this deviates from the mean, if I said before up here that I could sell 2 or 3 appliances, this is my mean. Okay. If I'm saying 1.5, I would probably round that up to about 2. So that means 2 more or 2 less than what we're saying our mean is. So if we said 2 less, if I subtracted 2 from this, right, that would be 0. And if I added 2 to that, that would be 5. So what this states is it gives a little bit bigger range of an idea of how many appliances could be sold. So on a given day, I can expect to sell 0 to 5 appliances. So if you're applying the standard deviation in this case, it kind of gives you a broader range of numbers for that. The next example, are we influenced to buy a product by an ad we saw on TV? The National Infomercial Marketing Association determined the number of times buyers of a product watched a TV infomercial before purchasing the product. The results are shown as. And so it says this category is 5 or more, but will be treated as 5 in this example. So it's just kind of, they're saying this would just represent anything above 5. That's what that little writing means. So number of times seen, 1, they thought it 20% of the time would get a buyer. 2, 31%, and on. So it says find the expected number of times buyers watch a TV infomercial before purchasing, calculate the standard deviation. Okay, so I actually kind of wrote some things down after I paused that just for a minute. I had an interruption and then I didn't record, but this column right here is like your X values, and this is like your probability, but we need to look at it like a decimal. We're going to have to find the mean before we can go find the standard deviation, because if you remember on the example before, I use the mean in every single calculation of finding the standard deviation. So we're going to have to do that. So we're taking 1 times 0.27, 2 times 0.31, 3 times 0.18. And then 4 times 0.09 and 5 times 0.15. And I haven't done this problem before today, so I will be doing a little calculator work. It's take me a little longer. So 0.27, 2 times 0.31 is 0.62. 3 times 0.18 is 0.54. 4 times 0.09 is 0.36. 5 times 0.15 is 0.75. Okay, and then remember what we do is after we multiply that, we sum all those things together and add them. So 0.75 plus 0.36 plus 0.54 plus 6.62 plus 0.27. And that is 2.54. So my mean is 2.54. But they want to know the standard deviation. So this means, if you remember, it would be between 2 and 3 times seeing the infomercial that they bought the higher chance, I guess, of them buying the product. So we now need to go do the one that takes a little bit longer. So we're taking 1 minus the mean. We're going to square it. And then we multiply times the probability. 2, 3, 4, 5. At least we don't have 7 this time, right? Oh, there should be a parentheses out there. Okay. So I've got the left-hand side of the operation all done. And then now we're going to do the right-hand side where I need to multiply times its probability, which really is just kind of right here. And then I'm going to pause the video and do all the calculations and then rejoin. Okay, so I've done all the calculations. Definitely check me. I haven't had this problem worked out for some time for some reason, so I didn't have the solutions with me when recording today. So remember, this was the formula for your mean. Your standard deviation was that sigma, that you're gonna do all that work. You're taking the square root of the sum of your x minus your mean. So that's what we did here. Our x minus the mean. We square it, then we multiply it times the probability of x. So I've done all of that work underneath. Now I just need to take the square root of it to find my standard deviation. So the square root of 1.87 is 1.37 when we round it. And so that would be like that would be one more, or 1 to 2 more or less in this case. Well, not 1 to 2. So our mean represents between 2 and 3, right? Our standard deviation, we would just go ahead and round it up and say, because it was above 1, I don't know, actually it's closer to 1. I don't think it would have those weird rounding rules. I would say more or less by 1. So this would mean that find the expected number of times buyer watched a TV infomercial before purchasing. So if this was between 2 and 3 times, if we would have written an explanation like we're supposed to for each one, we would have said they would have watched it 2 or 3 times before they bought. This standard deviation means 1 more or 1 less. That's where I was going a minute ago, and I got all mixed up with my mean, I guess. So I would subtract 1, and I could say between 1 and 4 times. So buyers watched infomercial between 1 and 4 times before purchase. Is a way that you could explain that, since it only asks for standard deviation, but we have to go through our mean so that we can go find the standard deviation.